A very good day, and we are from group number 8, section 9, and we are presenting about a subject which is like advanced manufacturing technology, and we are doing a part of directional solidification of carnivores. And in this presentation, we are required to do research on articles which was like 2017 and above, and we are here to do the presentation. And from now, and I'm Thipan Tanigajalam. My metric number is CD190307, followed by Praveena K.PARAMASIVAM DD190017, and followed by Mr. Wahiduddin bin AB Wahid CD 200-141, and followed by 1 EZANIE NADIA BINTI 1 MOHIZAN, metric number DD190014, and we'll be presenting about directional solidification and carnivores. And today, let's move on to introduction. Next slide. In this introduction, we are basically gonna see and we're gonna did a research. What is like directional solidification? What is the line of solidification? How does it work? The fundamental causes of the laws of this type of solidification. So these are the very basic things we're gonna see about. Like example, more than an example, let's see what is like a metal casting word is a directional solidification. What is a directional solidification? It is the controlled feeding of a molten metal into a temperature controlled mold to produce a product devoid of shrink flaws or empty region. Empty region means it's something like a mold. So they're gonna like pour like some kind of metal molten into the mold, the specific mold, to do the casting. So in this process, that's what we're going to see, like directional solidification. So in this directional solidification, we're going to see the line of the solidification advances gradually upward towards the molten metal feed as the metal at the bottom of the mold cools. At this point, the shrink flaws may be addressed by adjusting the pace of molten metal feed and producing temperature fluctuation in the mold. Since the liquid metal will naturally run into these dips and unoccupied spots, the progressive solidification, often known as parallel solidification, it is not to be confused with directional solidification. So they are, it's like different between like parallel solidification, like directional solidification. The fundamental cause of flaw in the casting is a parallel solidification. As a result of solidification, thermal expansion and construction flaws are created at the molten metals called cools. And L-shaped molds, for example, the metal is mold corner may cool too rapidly, generating bottleneck and trapping and air pockets in the lower lid. The air pockets weaken the overall structure, creating hollow region in the completed metal item. So it is a risk part at this some point. And moreover, the several strategies are used to the casting process to control the parallel solidification and stimulate the directional solidification, to regulate the hot and cold region, but also to maintain the cause of difficulties with the cast component. Rises or chills are used to introduce thermal changes inside the mold. Insulated sleeves are used also utilized to keep the mold at a consistent regulated temperature. Finally, to guarantee the directed solidification, the rate of flow and temperature of the molten supply are carefully regulated. So in this topic, we will like see further on other aspects and terms, and from this is my part, and Mr. Wahidin will be continuing his part.
Assalamualaikum, and I will be continuing into my part, which is a literature review. So, based on the literature review, we have discussed about a topic, which is a topic from the past 2020, which is directional solidification process of an aluminum alloy bar in multi-shell mold being gradually immersed in water. So in this part, we will see about how benefit it is this technique toward the mold toward the items. So save. Firstly, the first point is it will be save times. The water cool solidification of the bar was 5.8 times faster comparing to air natural cooling. And the second point is bring improvement. Based on the research paper, it was stated that SDAS, which is stand for secondary dendrite arm spacing, and eutectic silicon were both improved greatly due to this technique. The tensile strength, elongation, and hardness were all enhanced dramatically compared to normal cooling. So, in terms of microstructure comparison, between the one immersed in the water, it was stated that the one in the water have better condition compared to normal cooling, which has rough border, uneven, sharply countered. So next we go to the methodology, which is the procedure, which the first is the concept was to melt the aluminium first before pour into the mold. The water level proper the advancement of the solidification front from bottom to top as the multi-shell mold was gradually immersed in the water. So the four thermocouple, which will be level P1 to P4, were used to monitor cooling at various height of each bar. The upper section of the multi-shell mold was insulated from the heat and the bottom was kept cold by the water. The mold was cooled in a water tank after pouring, with the water level gradually rising. Water flowed into the shell, spacing and encircle the innermost shell, providing excellent cooling and propelling the solidification front upward. Meanwhile, the multi-shell act as insulator from the casting upper portion. So based on these figures, there is a comparison between the normal cooling and the using immerse in water cooling technique, which it was shortened quite a lot compared to the normal one. So that's all from the methodology part, and we will further analyze into the next part.
Hi, Assalamualaikum. My name is EZANIE Media MOHIZAN. I'm going to talk about the theoretical modeling for this research. So, Chvorinov rules is a mathematical connection that connects the solidification time for simple casting to the casting volume and surface area. So, the rule states that a casting with a high surface area and small volume cools faster than a casting with a small surface area and large volume under identical conditions. The riser is designed using the thermomodulus approach as previously stated. Risers are typically chosen to have a longer solidification time than neighboring casting sections to ensure adequate feeding. So, as demonstrated in the equation, Chvorinov rules offers a link between solidification time and modulus. Next slide. In the article analyzed that mole constant and thermomodulus when determining the shape parameter of the Chvorinov rules for the HPDC using optimization parameters such as temperature, pressure, velocity, and holding time. The M is referred to thermomodulus. This equation accounts for the volume and surface area as well as the type of casting procedure. And the next, V is referred to mode constant. So to find the shape constant, experiments on simple geometric shape, a cylinder is considered for simulation analysis. The experimental work carried out was on the simple cylinder of dimension 40 millimeter radius and 100 millimeter height. At first, the parameters such as thermal modulus, mole constant is calculated. Parameters are required such as thermal conductivity, initial temperature, specific heat temperature, latent heat, and density to calculate the mole constant. So the thermal modulus as described is the modification done to its conventional type Only the volume ratio to the surface area was taken primarily for sandcasting in its conventional model. By using the equation, the calculation and simulation analysis of geometric shape for cylinder is evaluated. Then we got n equal to 1.2. As for that, temperature hotspot distance was calculated using the injection point as the origin and verified with simulation analysis. So here we got H is equal to 119 millimeter. Simulation analysis for a cylinder shows that the thermal peak is approximate 49 millimeter from the origin. That's all from me. Thank you.
So I'm K.PARAMASIVAM. I'm going to discuss about the experiment setup of our group assignment. So according to our paper, from the research paper, the analytical way that they have been using is by using a software called Procast. So Procast is a go-to tool for a casting basic, like for filling, solidification, and prediction of porosity, pinholes, shrinkage, and most importantly, for our group assignment, it will be a hotspot, a prediction of hotspot in a casting model. Right, so in that way, the software was used to predict the thermal hotspot in the cylinder casting mode before we continue the process of casting into a real life situation or applications. The figure below shows the analytical analysis by using the procast, the flow of it. So initially we have to draw the cylinder mold with the riser using the SolidWorks and convert the file type into a IGS type. And the drawing will be transferred to procast and convert it to the model. And we have to choose what type of experiment that we want to run toward the cylindrical model. So, for example, like simulation or calculations. So all the requirements such as the data will be calculated after it generate the final element mesh model and setting the calculation parameters that we're going to use, and the simulation calculation will be displayed as a result. So the result will be including some important outcome like solidification time, hotspots, and so on. Next slide. So as for the result of analysis, so as for the result, after all the calculated data transferred into the software with its cylinder size and shape with a riser of a height of 70 mm, according to the previous article, the analysis for the temperature and thermal hotspot for the mode with solidity time was shown through the Procast software. So as we can see from the first figure, we can it is the before we run through the software called Procast, and another figure which will be on the right side is the one that we have run through after inputting all the parameters. So the simulated results for cylinder showing validation of temperature and thermal hotspot with solidification time which result in maximum height of 48.99 mm from the origin from the for shape constant 1.2. Next slide please. So from the above analysis, analytical one, the height from the origin of the cylindrical mold will be 48.99, which is approximately to the 49 mm, which is similar to the numerical analysis that was discussed by Nadia. So in that way, we can conclude that both analyses are acceptable, but the only element that makes it more reliable to the analytical one is visualization of the location of the thermal hotspot after the process of solidification. Because in a real life application, you wouldn't see the thermal hotspot since it cannot see because it's happening inside the mold. So a large area means large solidification times because of the large volume to area ratio. Therefore, the result can improve the casting mode by redesigning the riser with a different location or measurement. So as we know, the Chvorinov rule suggests that section of casting having a large volume to surface area ratio will take a long time to solidify, and such hotspot should be avoided when designing casting because of the potential of the porosity defects. So risers should be designed to conserve the metal. And that way, it is accomplished by taking into account the riser's size, form, and placement, as well as the nature of the connection between the riser and the casting. So Voronov rule may be used to compute the minimum size of the riser and making the total solidification time for the riser longer than the entire solidification time for the casting. That will be for me. Next part.
And thank you, Praveena. And we are here with the conclusion of the overall article that we have gone through. So, from the overall research that we have done, so we can conclude the utilization of the multi-shell mold construction and water immersion cooling method to achieve directional solidification from the bottom of the top of a bar is presented in this study. So, and then this is the one of the mold shell mold constructive method that we have been used. And then for the next conclusion, we can say the directional solidification is a solidification that occurs from the furthest end of the casting and works its way towards the spruce. Progressive solidification is also known as a parallel solidification, as we have like mentioned earlier, and it starts at the wall of the casting and progress perpendicularly from the surface. As a result, the structure has many microscopic shrinkage pores spread throughout it, and casting cools to room temperature after solidification, it contracts even more. And finally, we can see that since both will receive the same metal and in same mold, the mold constant will be same for the both region and like at this like particular region. And it's also have like safe difference in solidification time of 25%, and the risk percentage will be 25% longer to the solidify than the casting. And this is our conclusion for our this presentation. And I'm Thipan. Thank you.